In the perhaps not too distant future, every radio telescope on Earth receives the same massive data dump from what can only be an advanced alien species. It seems to contain the detailed instructions for building a faster-than-light propulsion device, along with a reference manual containing what amounts to all physics known by the aliens, including the equations of their laws of physics and a list of all elementary particles and their properties and interactions. If we can correctly decipher this stuff, we can build warp ships and join the galactic civilization. Of course, if we get it wrong, we'll probably blow up the planet. How hard can it really be to decode alien physics and engineering? I mean, it's got a map to our own physics. We live in the same universe after all. So we start by noticing that this alien technology seems to use good old-fashioned electronics, even if it is insanely complex. We know this because the particle carried by the alien circuitry looks like the electron. We decide this through a process of elimination. The aliens describe two sets of spin-half particles, each with 3 generations. These must be the quarks and the leptons, which are distinguishable from each other by their relative masses, color charge, etc. The particle running through the alien circuitry is the lightest lepton and has negative electric charge. Obviously, the electron. Actually, no. Unbeknownst to us, these aliens use positronic circuitry, not electronic. It's just that they define electric charge in the opposite way. Electrons positive, positrons negative. But how could we make such a blunder? Surely a quick glance at the alien Maxwell's equations, which govern the interactions of charged particles, will reveal that they use a flipped sign convention. Nope. It turns out that not only is the sign convention arbitrary, but there's no way to tell which was chosen based on the laws of physics alone. So we build the device with its incorrect electronic circuitry. The president exerts some pressure to switch it on already because an election is coming up. But just before we flip the switch and destroy the planet, a few cautious scientists take one last look at the alien documentation. So what do you think? Is there anything in the way the aliens wrote down their laws of physics that might reveal our error? Before we figure that out, let's recall how we humans decided on our own electric charge sign convention. It was a pretty arbitrary choice made on a mistake. Made by this guy, Benjamin Franklin. The nature of electricity was just one of Franklin's many scientific interests. Now, by Franklin's time, we already knew that if you rubbed a glass rod with a piece of cloth, both gain an electric charge. Franklin was the first to guess that both rod and cloth gain the same type of charge, just with opposite signs to the charge. He imagined an electric fluid that flowed from one to the other, so that if you have an excess of this fluid in one, then you have an absence in the other. Then, the direction of the force comes from multiplying the signs of the density of this fluid together. Bring together 2 positive charges or 2 negative charges, and you get a net positive force, which means a repulsive force, by the way. But a negative and positive charge brought together leads to a negative force, and that is an attractive force. The choice of sign convention doesn't actually matter as long as you stay consistent, which is lucky because the reasoning behind Franklin's choice was wrong. He noticed that when you rub the glass rod with the piece of cloth, you can get a more powerful shock from the rod compared to the cloth. He imagined the electrical fluid building up in the rod and flowing into your hand, so he defined the rod's charge as positive. We now know that it's the other way around. Electrons from the rod are actually rubbed off onto the cloth, so there's a flow of matter in the opposite direction. You get a stronger shock from the rod because the charge moves around more easily inside the glass. That means a large charge difference builds up in the rod near your point of contact, and that causes electrons to jump from your hand into the rod. This was all in the early part of the 1700s. It was a century and a half later before we actually discovered that the electron existed. That discovery finally allowed us to figure out which way this fluid was really flowing, but by then it was too late. What we now call the Franklin convention was fully entrenched. Electrons came to be defined as having negative charge, and that defined the relative charge of everything else, including the positive charge for protons and positrons. Happily, Benjamin Franklin's misguided choice doesn't make any difference to the laws of electromagnetism, the Maxwell equations. Those equations tell us how particles with electric charges respond to each other. They don't care what names we give those particles. Had Franklin defined charge the other way around, Maxwell's equations would be unchanged. But this is bad news for our fictional scenario, because we can't rely on the equations describing the laws of physics to determine the alien sign convention for electric charge. Our problem is compounded by the fact that matter and antimatter seem to be identical except for having exactly opposite charges. The universe is mostly symmetric under charge conjugation. Switch all matter with antimatter and vice versa, and the universe would keep ticking along almost exactly the same, but not quite exactly. It's clear that the universe itself knows the difference between matter and antimatter. After all, it contains almost exclusively the former. And that fact tells us that somewhere buried deep in the laws of physics is a subtle breaking of charge symmetry. So, in order to save the world from poorly assembled alien technology, we need to find a single manifestation of this symmetry breaking. The classic example is the decay of the kaon particle, which we've talked about in detail previously. The long story short is that this unstable meson decays very differently compared to its antiparticle. As long as our compendium of alien physics describes the interactions of specific particles, we can distinguish matter from antimatter in the case of kaons. That breaks the frustrating symmetry of the entire alien system of physics, allowing us to identify the charge sign convention, distinguish positrons from electrons, and hopefully not explode the planet. But maybe we're not quite there yet. The Franklin convention for the sign of electrically charged particles is not the only arbitrary choice that we made in our development of the laws of physics. What if the alien physics made other choices differently? Let's say that this rather finicky device also cares about the handedness of the positron. Weirdly, there are right-handed and left-handed versions of all particles with quantum spin. If we build the device with positrons that are spinning the wrong way, then, I don't know, maybe we create a black hole that eats the planet. But the definition of handedness also depends on an arbitrary convention, just like the sign of the electric charge. In this case, it's something called the right-hand rule. Let's put aside quantum spin for a minute to define this rule. Say you have an electron moving through a magnetic field. That field is going to apply a force in some direction to that electron. To find the direction of that force, you just point your index finger of your right hand in the direction the electron is moving, and your middle finger in the direction of the magnetic field. Then your thumb will be pointing in the direction of the force. Mathematically, we calculate the force using something called the cross product. Force equals charge times velocity cross magnetic field. This is a type of vector multiplication where the direction of the final vector, in this case force, can be found using the right-hand rule. Cross products are everywhere in physics, for example in calculating torque, angular momentum, and through Maxwell's equations. The right-hand rule is another arbitrary convention, and its choice also determines how we define particle handedness, also known as particle chirality. What if our aliens are predominantly left-handed, or left-tentacled, or whatever? They might define chirality in the opposite way with devastating existential consequences. Fortunately, this switch in convention does seem to change the actual equations of the laws of physics. To make a left-hand rule work, you need to either flip the order of the two vectors in the cross product, so field cross velocity instead of the other way around, or you need to add a minus sign in front of the equation. So it sounds like we could figure out which conventions the aliens used just by looking at their Maxwell's equations. But actually no, at least not without other information. To understand why, imagine that all right hands in the universe were transformed into left hands and vice versa. In other words, imagine reflecting the whole universe in a mirror. We call such a transformation a parity inversion. Parity is another fundamental and broken symmetry of nature, like charge. And just as with charge symmetry, parity is related to an arbitrary convention, the right-hand rule. In fact, charge and parity are intimately tied. I just told you that you can undo the effects of using the left-hand rule by placing a minus sign in front of your magnetic force equation. Well, that minus sign can equally be interpreted as a flip in the sign of the electric charge in that equation. If you change the convention for parity by using the left-hand rule, and you change the convention for charge by flipping its sign, then the differences cancel out and you're left with the same laws of physics. So, can we figure out what parity convention our alien benefactors are using? Well, only if we also know their sign convention. But if we don't know that, then there's no way to tell from the master equations themselves. But just as with charge, if we dig into the way particles interact, we can find a clue. Parity is the symmetry between left and right-handed chirality for particles with quantum spin, and in our universe, p-symmetry is broken in much more obvious ways than charge symmetry. That's because the weak force only interacts with left-handed particles and with right-handed antiparticles, not at all with right-handed particles nor left-handed antiparticles. If we search the alien user manual for the part that describes weak force interactions, we should be able to figure out which handed rule the aliens are using. But again, this depends on our ability to distinguish matter from antimatter, so we still need to know which sign convention they use for electric charge. The combination of charge and parity transformation appears to bring our equations back to where they started. This is CP symmetry. A mirror-reflected antimatter universe has the same laws of physics as ours. But actually, such a universe works differently in very, very subtle ways. That universe works just like our universe if you reversed the flow of time. The final symmetry and the final convention that we need to figure out is how the aliens define the flow of time. Do they define the future as an increasing progression of positive times like we do, and the past as negative, or do they do it the other way around? The laws of physics shouldn't care which you choose, so we say those laws are time reversal symmetric. But if time reversal is equivalent to charge parity inversion, and the latter is a broken symmetry, then time symmetry must also be broken. The grand, unbroken symmetry, CPT symmetry, is a combination of all three. The laws of physics and the behavior of nature is unchanged under simultaneous inversions of charge, parity, and time. And here we might have our final insurmountable problem. What if the aliens use reverse conventions for the sign of electric charge, the handedness of parity, and the direction of the flow of time? The change in the time flow convention, along with the changes in charge and parity, would alter how they represent their particle interactions in a way that we couldn't distinguish. We might build a time-forward, right-handed electronic device instead of the aliens' intended time-reversed, left-handed, positronic doodad. And guess what? That should be totally fine. The unbroken nature of CPT symmetry means that the thing should work just as intended. Like assembling a bookshelf upside down because you inverted the instruction manual, the thing still holds books. It may be embarrassing when we warp into the galactic civilization with our spaceship on backwards, but the important thing is we get there. The takeaways from all of this. 1. Check if your alien instruction manual is upside down. And 2. Remember that whenever we measure something, anything, we are making choices. Those choices can seem inconsequential, but every seemingly arbitrary choice reveals something powerful. It points to the existence of an underlying symmetry of space-time.